Yeah, hello everyone. Welcome to the part 2 of the webinar, Unlocking the Benefits of AI-driven predictive maintenance in oil and gas process industries. We meet all of you once again, and thanks for joining us in this part of the webinar. In the last part of webinar, we saw how can you create a return on investment on such a platform adopting AI-based predictive maintenance paradigm in your operations. We also saw one of the early adopters of this platform, what kind of benefits they have obtained from such a platform, and also the challenges and the mechanism in which they entered into such kind of a maintenance paradigm. So today we will deep dive into specifics of the platform, and also see specific use cases which are relevant to your industry. We will have a presentation for first part roughly about 20 minutes to go through the platform, and then look at the use cases, followed by question and answer session. So please keep your questions in your chat window if you're seeing in your panel, and we will attempt to answer those as soon as possible. So I invite Trevor Bloch, CEO of VROC, to start his presentation.
Thank you, Syed. Just going to share my screen. I hope you can see that. So as Syed mentioned, this is the second part of this webinar series. In the first part, we spoke about the business impact of this technology. And we talked to Razik from Petronas, who was very forthcoming and discussed how Petronas engaged with VROC, and in particular how they were able to deploy this technology onto their assets and achieve measurable business benefits and savings. So now that we've seen the business benefits, today we're going to look at how we actually implement this technology. So how do our clients go from having no advanced analytics or very basic analytics to a full digital predictive maintenance and optimization system to realize the value provided by this technology? So if we look at the components of the VROC solution, which is just a recap from part one, there's sort of four main components. We have performance monitoring, which is, I guess, monitoring your assets and ensuring that it's performing adequately. We have the predictive maintenance, which is predicting failures and undesirable events before they happen so they can be prevented. So this includes preventing unplanned downtime and equipment failure. We have process optimization, which is obviously optimizing the processing of the facility. And we provide expert support, which is tying all that together and ensuring that users get the most out of the system and are able to implement this as part of their normal working environment. And what we're finding from most of our clients recently is that they generally start with performance monitoring and predictive maintenance. That's the key driver for deploying this sort of technology. But after 6 or 9 months, when they have this technology deployed through their organization and they're successfully raising work orders to fix problems and repair equipment before failures occur, once they've come to the end of that predictive maintenance piece and everything's working properly, they then move on to process optimization, which is the next area that they can focus on to gain more value from this technology. And I guess the solution that we're providing to clients covers all those areas. And as I mentioned, we have the expert support as well, which is there to provide guidance and assist them through this journey. So the agenda for today, we're firstly going to go through the VROC philosophy, so the methodology, how our system works and how it differs from possibly a lot of the others that you may have seen. We're going to look at the VROC deployment and engagement process, so how do we deploy and scale this technology through organizations. I'm going to give a live demo of the VROC model wizard. So this is a key feature or key component that drives the methodology that I was talking about earlier. And then after that, our chief data scientist, Dr. Sia Doshvapasan, is going to go through a use case for you and provide a deep dive into some complex problems that we've recently solved for some of our clients. So if we start off with the methodology, VROC has a philosophy whereby we're trying to enable or empower the whole team to use big data to solve problems. So we're trying to, I guess, provide the data science capabilities to your whole organization without everyone having to learn how AI and big data and data science actually works. And so if we compare it, if we look at traditional data analytics, which is the top half of this diagram in orange, we see that in traditional systems or traditional data analytics where predictive maintenance is performed, the end user generally has a problem. So they want to predict when the compressor is going to fail next. They might want to predict the next flaring event or other process upsets. They have a lot of problems. And so what they do is they take these problems and they send them to a data science team. And so the data science team then manually models those problems. So they call in subject matter experts, they look through the data, and they try and find methods and ways to solve these problems using standard data science techniques. This process generally takes in the order of months. And so once they have a solution, they then deploy that solution back into production for the end user. And typically you get a very high quality solution that is extremely effective and provides good insights into the particular problem that they're trying to solve. The only issue with this methodology from our perspective is that it's quite slow in the fact that it takes 3 months and it's very labor intensive. So for each problem that you want to try and solve, you need to go through this process of 3 months and a lot of manual modeling to solve the problem. What we're trying to do at VROC is we're trying to automate a lot of that. So rather than the end user giving the problem to a data science team, what they can do on the VROC platform is they can enter the problem in the VROC browser, in the VROC platform itself. So they can go onto the web browser, log onto the VROC site, and go through a number of wizards to enter all the information about the problem they're trying to solve. So they're still solving the same type of problems. They're still trying to predict when their compressor is going to fail next. They're still trying to predict the next flaring event, or when they're going to get the next sand problem coming through their facility. But rather than having to give that problem to the data science team, what they can do is they can enter that problem into the wizard, and the wizard will go through and ask them all the relevant questions and request all the information that it needs to solve the problem. And once they've entered all that information, the system will then go away and it will produce secondary and tertiary features. It'll look at the problem from various perspectives. It may produce hundreds or thousands of models in the background, and it will try using the toolkit that it's got built in to try and solve that problem. And so the beauty about this is that rather than the end user having to understand data science or artificial intelligence, all they have to understand is about the problem they're trying to solve. Once they enter it into the wizard, the VROC system automates the whole process of building the AI model from that data set. And so once it's finished, it then sends a notification by an email saying, this is the problem you asked me to solve. I can solve it with 95% confidence, and this is what it looks like. Do you want to put that model into production? And if the end user is happy with that, they can then put that model straight into production, and they've got a live AI model predicting the next compressor failure or the next flaring event or whatever they're trying to do. The beauty about the automated system is that rather than taking weeks or months to solve that particular problem, this problem can be solved in a matter of minutes. So half an hour or an hour is not an atypical time to solve these sort of problems. And so what this technology enables you to do is, rather than sending all these problems to your data science team, the engineers themselves and the subject matter experts can self-serve on the platform, and they can solve problems themselves. So you have all your mechanical engineers, your electrical engineers, your reliability engineers, all building models of the problems on the facility that affect them. And so you end up with this huge library of models that are built that are monitoring the critical parts of your facility, built by the experts in each part of that facility. And so that's the key to the platform, is to democratize this data science and empower the whole team to build models to monitor all the critical aspects of your facility in real time. Now, if we look at the typical system architecture of this system, it's a pretty standard big data SaaS type architecture. We have data from your existing sensors, from your data historians, from external data sources like CMMS systems or SAP or lab results, whatever data you've got. That's all sent via secure communications into a data center where the data is collected. And within that data center, we then do the AI and data processing. Once we've got the results, we then present it to the end user on user configurable web dashboards. So you can see that once we have results, we have on-site personnel, off-site personnel, and management all being able to view these dashboards and getting data that's relevant to their needs. Of course, we provide expert support. So if people need help interpreting the results or building models, we can provide that as part of the service. All right, so if we move on, the hosting options. So we saw that data center where we host the data and where we provide the insights, we provide a number of different hosting options for that data center. So what we find is most clients initially will use a VROC private data center. So we have our own data centers around the world where we can quickly and effectively process your data. And the beauty about that is that you don't have to set up any of your own infrastructure. You simply stream the data to us, and we're able to process it and provide you results almost immediately. If you prefer to have the data in your own data center, then that's fine. We can have an on-premise data center where you provide server space for us, and we can install our software in your own infrastructure. Similarly, if you have a client public cloud like AWS or Azure, we can install the solution in your own infrastructure on your own public cloud. The fourth option we have for deployment is the VROC Cube. And the VROC Cube is essentially a pre-configured VROC solution in a box. So if you want to implement a predictive analytics solution in your organization, you can order a VROC Cube, which comes as a rack pre-configured with the VROC software on it. You just wheel the rack into your data center, you plug in power, and you connect the network, and then you've got an off-the-shelf plug-and-play solution for predictive analytics. So those are the 4 deployment options that are designed to I guess, fulfill any requirements that companies have for their data security and privacy. So now, if we go through and we look at the typical lifestyle of the solution, so essentially what we're trying to do, it is quite a big change for an organization. So we're trying to change the way that you perform maintenance and to change the way that you maintain your facilities and your maintenance team actually operates. So it is quite a big change, and we try to gradually steer clients through this process. So we start off with the initial 4 weeks, and this is where we're gathering historical data, setting up real-time streaming, ensuring that the ingestion is reliable. We also provide the training for your end users, so both management and end users go through our training programs, and we start producing the first AI model, so you can start understanding how this technology works. After the first 4 weeks, we then provide ongoing business support and as well as maintenance and support, and that's designed to ensure that you're getting the most out of the solution. Obviously, when you start using this technology, there is a bit of a change to the way that you normally work. There's also a change in the way that you perform reliability analysis and how you interpret the results of these dashboards. So we provide full support throughout that process to ensure that your end users, which will be your engineers and subject matter experts, understand what's happening and have a smooth transition from what they're doing now to using this technology to improve their facility into the future. So that's a typical life cycle, and what we find is the support generally runs for a period of about 6 months, where we're quite involved and engaged to assist you through the process. And after that, we find that most clients are able to do this themselves, and they start training their teams internally, and we provide just support as required after that point. So that's a typical life cycle of a VROC engagement. Now, if we go back and have a look at the main, I guess, features or functions delivered by the VROC solution, we mentioned performance monitoring. So performance monitoring is really a high-level view of your facility and how your whole asset is performing. So it's very different from a historian. So a historian just shows you sensor values and what's happening at the moment. These performance monitoring dashboards are the culmination of all the AI models that everyone's been producing. So as I mentioned, we've sort of democratized this data analytics, and so all of your team are able to produce models for whatever problems they're trying to solve. And what the VROC solution can then do is aggregate all those models up to a high level and give you an overview of how your whole plant is functioning. And so you can see by this dashboard, this is just a simple traffic light one that this client has elected to use. They can get a very quick snapshot of what's going on and the health of all the parts of their facility. And I've got a quote here from one of our oil and gas maintenance superintendents who said that, I love the software, it gives me confidence that my equipment is working and that we're on top of our maintenance. And that's essentially what we're trying to do here. All of these green boxes mean that everything in that area of plant is operating correctly and we don't need to take any action. The only plant areas that we need to look at are these yellow and red ones where we can see some degradation and the AI has identified that there's something going on there, so we need to investigate. So the people in charge of these green areas don't really have to do anything at the moment. They're pretty happy that everything's okay. But as soon as the AI starts detecting some issues, that's when we know we need to take some action. So it's giving them confidence that they know what's going on and they know where to focus their attention on their plant at all time. The data from these systems, so all of this data that you see on performance monitoring can then be fed through to a digital twin. So if you're looking to do digital twins on your assets, which might be a 3D VR or AR model, where you can scroll around and see what's going on, all of the data that we're providing here can then be overlaid onto those models. So not only can you see physically how your facility looks in real time and what all your process parameters are, but you can also see the health of the equipment, you can see the health of the subsystems, and you can perform RCA all from that one interface. So we integrate quite readily with all types of digital twin visualization software. We don't do that as our core business, but if you want to do that, we can assist you with providing the data to visualize that, visualize this analytics onto your digital twins. Predictive maintenance. So one of the key features that we provide is predictive maintenance, and predictive maintenance is obviously trying to reduce the number of unplanned failures or undesirable events that happen on your facility and to identify the root cause. So we want to try and identify a failure or undesirable event before it happens, and then we want to identify what the root cause is and what we need to do to prevent that thing from happening in the first place. And so you can see here we have some dashboards on the screen of predictive maintenance. So you can see the table view is actually one that was used by Petronas. And each row on this table view with the numbers on it is a piece of equipment. We obviously removed those for confidentiality purposes, but this first row could be a compressor and the second one could be a turbine generator. So for each piece of equipment, they've got an idea of the health of this piece of equipment. And so you can see on the first row in the very top left box, it says 68%. And so what that's referring to is a 68% chance of a failure in the first day. So your gas compressor has a 68% chance of failure. The next one down is your turbine generator has a 22% chance of failure. And so as new data comes into the system, these will shift around as the AI identifies the next failure to occur and the probability of that failure happening. And so what this gives you is a hit list of what you need to tackle first to keep your plant running. And a time frame over which you need to do it. Of course, 7 days is a short period of time, but this is just what this client wanted. It's possible to view analytics over a longer period if required. Again, all these provide full drill down. So once you identify a problem, you can drill down to identify what the root cause is and what you need to do to fix it. As you can see below it, we've got some other dashboards which are used by other North Sea oil and gas operators, which have more of a yellow-red bar graph, and then you've got the other contributing factors graph below that. So there's a number of different ways that people can view these dashboards, and we're actually just viewing the same data. So you can have the same analytic results viewed from multiple perspectives by different users. So as I mentioned earlier, once we've got our predictive maintenance under control and we're raising work orders preemptively to solve problems before they actually occur, we can then move on to process optimization. And so process optimization is things like mitigating production losses from sanding events, limiting moisture content in glycol separators, identifying what's causing oily water separation issues, which I believe Sia will discuss in depth shortly. But process optimization is something that we're providing more and more of because it's providing increased value once predictive maintenance has been brought under control. Similarly, if you have multiple identical processes, so you've got multiple trains or multiple identical pieces of equipment, and you want to do a comparison of why one train or one piece of equipment is functioning better or worse than the other, AI is perfect for that. So we can provide a number of analytics and visualizations to compare and contrast what's driving certain features and what's causing certain pieces of equipment to perform better or worse than others. So it's all part of the same software package. And we find that people, as I said, once they've finished optimizing their maintenance, this is a natural progression for them. And the software provides all of that as part of the solution. So as I mentioned earlier, that's a very, very quick information dumped on how the solution works. I'm going to give you a demo of the AI model wizard. And this is the wizard that the end users will use to build models on the platform. And I'm just going to take you through it quickly just to show you how easy it is to use. And now anyone can build models using this technology without having to have any data science experience. So generally what we do is, as you can see, we have a web-based interface here. And we have a number of use cases that people may want to build models for. And these are customized for different clients depending on what they require. But you can see from the 5 typical examples we have here, you might want to predict when the next failure or undesirable event will occur. You might want to predict what a value will be in the future. You might want to identify the root cause of an event, identify when equipment or process is degrading or not operating correctly, or predict when equipment maintenance is required. And so these are just 5 typical use cases that we see quite often. And so if you want to build a model for one of these, all we have to do is click through the use case. So if I want to predict the next failure or undesirable event, I can just click on this use case, and the model wizard will step me through the process of building this model. So let's say it says, what do I want to call this model? I'll call it compressor 1 failure. So I can call it anything I like. It's just for me so I can identify it in future. Okay, it's saying select the folder you want to store the model in. So again, this is just so I can find it later. So I'll just store it in our standard analytics folder. Now, because I've selected a model where I want to predict the next failure or undesirable event, I need to tell the system what is the failure or undesirable event I'm trying to predict. So in this case, what I'm going to do is I'm going to pick a tag here, which is the compressor speed. I'll just go back a few years to get some data for us. Here we go. So here's our data. And as we can see, this is some historical data, 2016 August to 2017 August. So that's 12 months of historical data. And we can see that the compressor speed, if I just scroll along this graph, is usually in the order of 95, 97% is the usual speed of this compressor. And so what I'm going to do is I'm going to call a failure whenever the speed is less than 80. Now this is a very simple threshold failure criteria. So again, we can have more complex criteria. We can have freeform calculations, or we can have multiple criteria if we want. But for this example, we'll just do a very basic criteria. We will say whenever the speed gets below 80, I consider that to be a failure or an undesirable event. And so what the AI is going to do is it's going to try and build a model that's going to predict when this compressor speed is going to get below 80. It's going to try and predict it before it happens and let me know what the root causes are. So what do I have to do to prevent that from happening in the first place? Okay, so I've told it what the failure looks like. Let's go next. So now it's saying select the optional condition when the model is active. So this is for some piece of equipment that may not run all the time. We can select some conditions here where we can tell the AI, well, these are the conditions under which this piece of equipment should normally operate. Now, again, we don't have to. This is optional, but if we want to give it a bit more information, we can limit the AI a little bit by giving it some specific criteria over when this piece of equipment should be running. I'm just going to hit skip because we don't need to enter an optional criteria there. So the next question it's asked for me is, would you like to select specific input features? Now this is used if we're trying to limit the way that these models are generated. So for example, if I'm building a model where I'm trying to predict the sand on the top side of my platform, but I only want to use data coming from the subsurface. So I only want to look at subsurface factors that are likely to cause sand events on top side. I can limit the input features and say, I only want you to look at subsurface factors that are going to cause this particular problem. Again, this is optional, so we don't have to do that. Oh, sorry, I've just clicked cancel. Just give me a second. I'll just go through one more time. Yeah, that one is optional, so I don't have to select something for that criteria. I'll just go through and type this in again. Give me a second. But if I want to limit the model, I can do that. I'll just change this to go back to 2016. Perfect. All right, so we're going to skip the activation condition. And for the specific input features, I'm going to skip that as well. And so now we've come to the end. So it's now giving us a summary of our settings. So we're going to predict when the next failure or undesirable event will occur. Our model name is compressor 1 failure. We're going to store it in this path. We're using the compressor speed, and our criteria threshold is when it's less than 80, we consider that a failure. For the activation, the model will always be active, and for refine input features, we're not going to refine the input features, we're going to let VROC find the model features. So at this point, I can then hit train, and the system will go away and actually build this model. So it'll go through all our data, it's going to build secondary and tertiary features, it's going to look at this problem from various different perspectives, and it's going to try various modeling techniques to try and build the best solution it can to predict when this compressor 1 failure is going to occur next. Once that's finished, that's likely to take half an hour or an hour. Once that's finished, I'll get an email. It's going to say the compressor 1 failure model that you tried to build or that you asked me to build, I can solve that problem with a 95% accuracy. These are the major contributing factors or the main tags that I'm using to solve the problem. This is historically how it works and what it looks like. Are you happy to put this model into production? And so the engineer can then say, yes, I agree with that. That looks fine. We'll put that model into production. And so at that point, as new data comes in, you're automatically getting updated insights from that model about the likelihood of my compressor 1 failure, and all that data is automatically appearing on all your dashboards and roll-ups, so you know exactly what's going on in your facility. So that's how the system works and how we can scale it quickly, because all of your end users are building these models themselves. Okay, so if we just move back onto our presentation now. So what we've seen is we've seen significant reductions in decision-making time and resources. We've seen significant reductions in downtime. We've seen improved productivity, improved reliability, improved safety. We've seen significantly improved environmental performance using this technology. And if you just have a look at this graph, this is actually one that we did for a client just recently, where you can see here, this is showing their production loss. So for this client, when they have an unplanned shutdown that causes them to not produce oil, they call it a production loss. And so this is showing you their production losses. So you can see 2019 production losses. The orange and yellow is 2 different platforms that they have. And we can see the production loss in 2019. And we can see in the blue box on the right, we can see where VROC was implemented. And you can see the significant reduction in production losses that we're experiencing once VROC was implemented. And you can also see these blue bars that go downwards, the negative section, which indicates predicted avoided failure. So these are failures that were avoided because of action that was taken by the operator because of a prediction made by VROC. So this company has seen an 83% reduction in production losses year on year after implementing this technology. So that's a significant reduction in losses. And if we just go back to a quote that Fadlan, the head of innovation at Petronas, mentioned at one of our earlier webinars. He said, in the span of 2 years, we've recorded close to $25 million worth of cost avoidance. So this is a quote from the head of innovation at Petronas on one of the platforms that we were monitoring for them. So I guess the business case for this technology is now sound, and people are seeing real savings. And so this is why we're seeing it not as a nice to have anymore. It's more of a mandatory technology that people need to implement to remain competitive in the current environment. And so with that, thank you for your time. I'm